So y'all, we'll start with 9.5 support. - 9.5 support goes over the properties of exponents. So y'all, support goes over these properties because remember, in the long run, logarithms are exponents. So when we go over the properties of the logarithms, they're sort of going to mirror these properties of exponents, okay? All right, so for the first one, we got what we call the product rule of exponents. You know, the product rule is what happens when we're multiplying variables. So a to the m times a to the n. If your variable matches up, when you're multiplying, then you add the exponents. And you always do that when we had x squared times x, we added 2 plus 1 and gave us a x to the third, okay? All right, the power rule for exponents is when I got parentheses being used. So when parentheses are being used and you got an exponent raised to an exponent, we multiply the exponents. So this will be a to the m times n. So multiply exponents when you got parentheses being used. Then we got our quotient rule of exponents. And that's for division. So if I got a to the m divided by a to the n, well, when you're dividing, you subtract exponents. You always subtract the bottom exponent from the top. So I get a to the m minus n. You know, the last exponent rule deals with negative exponents. All right, so there is a few cases of these. The first case is of this form. You got a number or a variable raised to a negative exponent. And the rule is you got to write things with positive exponents when you're done simplifying. So to make a negative exponent positive, I put this under 1 and change the sign of the exponent to a positive 1. So it's basically like you're flipping it and changing the sign of the exponent. Now, it could start out on the bottom and be a negative exponent. So if you got 1 over something to a negative exponent, to make this exponent positive, you would basically flip it and make this the a to the positive m. So y'all basically, you move exponents down or up to make them positive. And then the last one looks like a fraction, a to the b raised to a negative m. Well, y'all, the same thing I've been doing. To make this exponent positive, we would flip the fraction and get a b over a to the positive m. So moving exponents down or up, or flipping fractions changes these exponents to a positive sign, okay? So this support section had 5 problems dealing with these rules. All right, y'all. So number one says multiply and simplify. They're giving me x to the fifth times x to the negative seventh. So this goes to case one where I got a to the m times a to the n. I added the exponents. So this becomes x to the 5 plus a negative 7. So we're adding exponents since we're multiplying a variable times itself. Well, 5 plus negative 7 gives me a negative 2. But y'all remember this, I can't leave the exponent negative. So I've got this case going on, x raised to the negative 2. Well, I flip that, put this under a 1. So my final answer will be 1 over x squared. Now we're happy the exponent's positive and we can move on. So notice I used two rules on this one. I had to use my product rule and then my negative exponent rule. All right, y'all, same thing on this one. Multiply and simplify. Z to the negative fifth times Z to the eighth times Z to the seventh. All right, we got three factors here, but they're all being multiplied. So I'm going to use the product rule, which says I add the exponents. So this will give me Z to the negative 5 plus 8 plus 7. So three terms or three factors, then you got three numbers being added together. So we just add these numbers and get our final answer. So negative 5 plus 8 is 3. 3 plus 7 is 10. Now, this exponent's positive, so I don't have to do anything to that answer. All right, y'all, number 3, multiply and simplify. Oh, so now they're bringing out some parentheses here. 9c to the third times 3c squared. All righty. So since we got exponents outside the parentheses, we got to start with them using the power rule. But y'all, these two things don't have exponents. So we gotta give them exponents. So if you got a number or variable that don't have an exponent shown, it is a 1. And then the same thing over here, this 3 is to the first, and that c is to the first. So missing exponents are always a 1. So my first step is to multiply everything's exponents inside the parentheses times that 3. So I got my 9. 1 times 3 is 3. On the C, 1 times 3 is 3. And in the second parentheses, 1 times 2 is 2. So that gives me 3 squared. On the C, 1 times 2 is 2. All right, y'all, at this point, 9 to the third power would give you 729. C to the third. 3 squared is 9. And then I got my C squared. So all I did on that step, I just evaluated what these numbers are going to equal. Because y'all, my last step is multiplying here. So the 729 times 9 gives me 6,561. On my C's, when I multiply to C, I'm going to be adding the exponents. Because remember, C times C goes back to our product rule up here. So that'll give me C to the 3 plus 2. All right, so I get 6,561. C, 3 plus 2 is 5. So this one you had a little bit of the power rule where you had to distribute the exponent. And then down here we're multiplying, we had the product rule. Hey, I'm probably doing a few extra steps than y'all would have to do. I'm just wanting y'all to see sort of every step what I'm doing, okay? All right, y'all, there were two more of these. So number 4 for support, divide and simplify. So they're giving me a y to the 9th divided by a y to the negative 9th. All right, so this will go back to the quotient rule, which says we take the top exponent and we subtract the bottom exponent. Well, y'all, that'll give me y. Now, subtracting exponents, I get 9 minus a negative 9. Remember, you're subtracting, and if you got a negative exponent on bottom, that's going to give you two negatives in a row. But y'all, when you subtract a negative, that becomes a positive. So this is basically 9 plus 9, and that gives us a y to the 18th. All right, so remember, when you're subtracting and the bottom exponent's negative, it's basically going to turn into addition, okay? All right, y'all, number 5 is just a simplify. I got 4x y to the 4th squared. All right, so once again, you got things in here inside the parentheses that don't have exponents. So the 4 would have an exponent of a 1, and the x would have an exponent of a 1. The y has a 4 there. So missing exponents are always a 1. Because y'all remember, when I got parentheses with an exponent, I got to distribute that exponent through those parentheses by multiplying. So for my 4, 1 times 2 gives me 2. For my x, 1 times 2 gives me 2. For my y, 4 times 2 gives me 8. And y'all, the last thing I got to do is evaluate the number on out. So 4 squared would be 4 times 4, which would give me 16 x squared y 8. And then that'd be my final answer. So y'all, that's the trick on the support. Was it went over all those exponent rules, okay? So we will start with 9.5 properties of logarithms. Now, if you remember, logarithms are basically exponents in disguise. So these properties will be similar to the exponent properties, but not exact. So the first one, I had a product rule of exponents. I got a product rule of logarithms. So it says if I got the log of a product, so like a log base A of M times N. If I got the log of a product, I can rewrite this as a sum of the logs. So always remember that the product rule of exponents, the product rule, when you was multiplying variables, you added the exponents. Well, the product rule of logs, when you're multiplying the variables, you add the logs. Okay. I got a power rule of logs, just like I got a power rule of exponents. So this is when you got a log raised to an exponent. So if I got the log A of M to the N, notice it's not being multiplied like this one. This is the M with an exponent at N. So if I got the log of a number raised to an exponent, I can rewrite that as N times the log A of M. So it's like I'm taking this exponent and multiplying by log A of M, which is technically an exponent. So I'm still in the long run multiplying exponents here, okay? But y'all, the thing is, you just bring the n down to the front and write it as a product. All right, y'all, we had a quotient rule of exponents. I got a quotient rule of logarithms. That says if I got a log base A of M divided by N. Well, remember up here when I multiplied, I wrote that as the sum of the logs because we added the exponents. Well, remember when I subtract, I write that as a difference of the logs because we're subtracting. So I would have the log A of M minus, so remember it's always the top minus the bottom, which would be a log A of N. Okay. So product still got written as the addition, division still gets written as subtraction. Now you can go either way with these rules, okay? You can start out with a product, rewrite it as a sum. When we solve equations, we'll be starting out with the sum and add them and rewriting them as a product. So these go either way here, okay? Also for this section, recall the log of A to the A. If the log base matches the result, that answer is a 1. And then also recall the other property. Log base A of A to the M. Now, y'all, let me let one in real quick. So if we get this situation, we would technically bring the M down times the log base of A using the power rule. But the log A of A part equals 1. So in the long run, if you got the log of a base, well, for base raised to an exponent, y'all, in the long run, that is just going to equal the exponent. All right, so those are the properties we're going to be working with in this section. Okay. Rewrite a product as a sum. Power rule, when you got a number raised to an exponent, we bring the exponent down to the front and write it as a product. Quotient rule, we subtract the log of the top minus the log of the bottom. Hey, also my examples, we're going to start going through these properties. So for the first two examples, we're going to express as a sum of logarithms. Well, the only property that had anything being added was the product rule, which says I take a product and I rewrite it as a sum. So y'all, that's what the first two are doing. Number one has a log base 17 of 17 times 289. So my product is a 17 times the 289. So I'm going to distribute the log base 17 to both of these and write it as a sum. So I get log base 17 is 17 plus the log base 17 of 289. All right, this one would go further, but they don't want me to. They just wanted me to express it as a sum. So at this point, I can stop and be done. Now, number two, they're just sort of switching back between logs and LNs. So the ln of C times D. Now, y'all, here's the thing. This is the ln. That is not an I. ln. If you don't write it with an ln in the math lab, it'll mark those wrong, okay? But the product is the C times D, so I'm going to distribute the ln to both of these and write it as a sum. So I got the ln of C. So ln of C plus the ln of D. You know, at this point, you don't even have to use the parentheses. You can write this as the ln of C plus ln of a D, okay? And so the first two want to be expressed as a sum. The next two want me to express as a product. So this is talking about the power rule, where I ended up with a product. And remember, product means something being multiplied. So on these next two, this one is a log base B of y to the 14th. Well, all the power rule said that all I got to do is bring that 14 down to the front and write this as a 14 times log B of y. So now I got a product with a 14 being multiplied by the log B of y. So exponents we always bring down to the front of the log. All right, y'all, 4 is going to do an LN. But this one's going to be a little trickier. I got the LN of the 6th root of 7. So y'all, for this one, let me recall y'all something. On this one, you got to know how to change this square root or the 6th root here. You got to know how to change that into a exponent. So to change a radical to an exponent, we bring out the base, which is the A, and indexes like this of a 2, they become fractional exponents. So if this is a 6 like I had here, this would be A to the 1/6. If that was a 5, this would be A to the 1/5. So the radicals here, their number becomes the bottom number of the fraction when you rewrite it, okay? So the first thing I'll do, we'll bring out this 7 and rewrite this square root, the 6th root here as a fractional exponent. So that'll give me a 1 on top, and then the index, which is a 6, becomes my bottom number. So a 6th root is a 1/6, okay? All right, so now to write it as a product, here's my exponent now. I bring that exponent down to the front so that I get a 1/6 times the ln of 7. So y'all, the whole trick on this problem is to rewrite that as a fractional exponent, okay? All right, y'all, so let's see. Next, we're going to express as a difference of logs. So each of them 3 properties, they give you 2 warm-up exercises basically on all of those, okay? All right, y'all, this is where I rewrote them as the difference with the top minus the bottom. So log base t of p over 4. So you distribute the log and you always do the top minus the bottom. So I get a log t of p. So log base t of p minus the log base t of 4. So the top is always positive, the bottoms of the fractions are always negative. All right, y'all, same thing with the ln. They're doing an ln of m divided by n. All right, distribute the ln to both, so you get an ln of m minus the ln of your n. You know, over here, I'm just going to remind y'all, ln is really a ln, okay? So ln of m minus ln of n. All right, y'all, so then the next exercises. We're going to rewrite as sums or differences. Of logarithms. Hey, also, let me see. Number 7, I got a log base c of x squared y to the 7th and z. All right, I got parentheses, but there's no exponents out here, so I don't have to do that with that. So all these are being multiplied right off the bat. So since they're being multiplied, we're going to start out by writing them as a sum. then we're going to distribute log C to all three factors. So I'm going to get a log C of x squared plus my log C of y to the seventh plus my log C of z. So the first step was to rewrite the product as a sum. Now, I got to do something else. I cannot leave the exponents up here. So now I got to do this power rule and bring the exponents down and write it as a product. And y'all, two of these had exponents. So we're going to bring that 2 down and we're going to bring that 7 down. So this one will give me 2 times the log C of x plus this one will give me 7 times the log C of y. And then this one didn't have an exponent other than a 1 technically. So that'll stay at log C of z. So to be totally simplified and rewritten, after you do the sums, you got to bring those exponents down, okay? So if you notice, y'all, these properties is just doing a bunch of rewriting, but that's going to help us when we solve the actual equations, okay, in 9-6. All right, y'all, so let's move on to number 8. Now, y'all, this one's a little trickier. I got a log base b. Now I got a big fraction. On top, I got a P3 Q5 over M3 B8. So this one's sort of utilizing 2 rules in one. I got stuff being multiplied and I got stuff being divided. So here's the trick. You got 4 factors basically, the P3, Q5, M3, and B8. We're going to distribute the log base B to all 4 of these. Now, the 2 factors on top will be positive. The 2 factors on bottom will be subtracted. So I just go in order, do my top and then minus my bottom stuff. So I got a log B of P to the third plus my log B of Q to the fifth. So those 2 factors were on top. I said they were positive. The next 2 factors on bottom will be subtracted. So I got a log B of M to the third. And then minus my log B of B to the A. So your first step is really writing them as the sums and differences stuff, okay? Now remember, it ain't all the way simplified until I bring my exponents down. So I got to bring that 3 down. I got to bring that 5 down. I got to bring that 3 down. But y'all look here. This is a log base B of B to the A. When I was giving you the properties, I gave you an example to recall that looked something like this. Remember, I had a log base A of A to an exponent. Well, remember, this base matches the base of the result raised to an exponent. So, y'all, this part right here equals the exponent. So, recall that part, okay? So, this part, log B of B to the 8, I'm just going to replace that with a 8. So, let's rewrite this one as 3 log B of P plus bringing the 5 down gives me a 5 log B of Q. Bringing the 3 down gives me minus 3 log B of M minus, well, right here, the log B of B to the 8, that equaled 8. So for this one to be simplified, you had to bring the exponents down, and then you had to remember, if you put 8 log B of B, although that's correct, it's not in the most simple form. You got to get it down to an 8 on that one, okay? All right, y'all, for the next examples. So this will be where I'm sort of going in reverse here, okay? They want me to express as a single logarithm. So I'm going to start with something like this and end up with a single logarithm. So we're going the other way, basically, okay? So y'all, I got a log C of 5 plus a log C of 21. So if they're being added, we rewrite them as a product. Since the product is rewritten as a sum. So what I'm going to do is we'll bring up that log base C, and then rewrite the sum as a product. That's going to give me 5 times 21. All right, so my last step would actually be to multiply that. So I get a log C, 5 times 21 gives me 105. So we're going in reverse now. Things that are being added get multiplied. Things that are being subtracted get divided, okay? Now, y'all, this one has log of 100,000 minus the log of 10,000. So see, these ones are being subtracted. So being subtracted, we rewrite them as a quotient. So bring out your log. Now remember, there's not a base on these logs. So these are common logs, but they do have a base technically. The base on these would be a 10 technically, remember, if there's not a number there. So y'all, this is the log of the 100,000 divided by the 10,000. So the subtraction got written as a single log of being divided. Well, y'all, we can go further than that. 100,000 divided by 10,000 gives me a log of 10. All right, so technically they give you this answer, but then it says this simplifies to what? So a log base 10 of 10. And y'all push that on the front of your calculator. See what does a log of 10 equal? So one of y'all got a calculator, right? So let's see.
1.
So it is a 1. Good job. And then put that 1 in. So this will have you do the log 10 as the answer, but then it says, hey, this simplifies further to a 1.
So basically, once it goes from the log 100,000 over 10,000, when you simplify it to that log 10, it's kind of going back up to at the top where you did number 10, where it has the implied log 10.
Yeah,
Okay.
yeah, yeah. Anytime you don't see a base there, it is definitely a 10 there, okay? All right, y'all. So let's see. LN of x squared plus 12x plus 27 minus the LN x plus 9. So being subtracted, so I'm going to rewrite them as a quotient like I did right here. So I'll bring out the LN. On top, I'll have an x squared plus 12x plus 27 over my x plus 9. So this one's a little tricky because to simplify this one, we got to factor the top and see if we get any factors that'll cancel. So y'all, we're going to factor the top. Now, there's just an x plus 9 on the bottom, so you cannot factor an x plus 9. You got to get these x squareds in order to factor them, okay? So the x squared makes an x in the front of both of these. Now, since this 27 is positive, both of these factors will be positive like the middle number. So now I need factors of 27 that'll add to get 12. So y'all, let's see. 27 is 1 times 27, 3 times 9, and that's it. So the factors that'll give me 12 are going to be 3 and 9. Well, y'all, if this was going to simplify, it made sense that one of these factors had to be an x plus 9, right? Because if I didn't get an x plus 9 on top, it wouldn't simplify. But this will now simplify because that x plus 9 will cancel with that x plus 9. And we're left with ln of x plus 3. And y'all, on this one, you must keep the parentheses. So you must keep parentheses. Because what will happen if you don't keep the parentheses, it'll treat it as an ln of x plus a 3. Okay? All right, and let's see this one. This one is a log x squared plus 9x plus 8 minus a log of x squared minus 1. So once again, they're being subtracted, so we'll write them as a quotient. So a log on top is x squared plus 9x plus 8. On bottom, x squared minus 1. So both of these are x squareds, so both of these will factor. So bring out the log. So let me start with the top. X squared is an x and an x. Last side's positive. So both of these factors will be positive like the middle number. Factors of 8 that'll give me a 9 are 8 and 1. So if something's going to cancel, I need an x plus 8 on bottom or an x plus 1 on bottom. Well, all this stuff right here, x squared minus 1, this is the difference of perfect squares. So the x squared will be an x and an x. This last number is negative. Anytime the number's negative, you get unlike signs. And then the square root of 1 is 1. So you would put a 1 and a 1. So remember, x squared minus 1, x plus 1, x minus 1. If that was a 4, I'd have a 2 and a 2. At 9, that'd be 3 and a 3. So you're basically just taking the square root of the number to get your two numbers here, okay? And remember, that's like if you solved it by square roots, you would add 1 and then do the square root. Well, a square root of 1 would give you a plus 1 and a negative 1, okay? But y'all, we were right. If something was going to cancel, it had to be one of these two factors. Well, this x plus 1 will now cancel with that x plus 1. So my final answer would be log. Now, since I still got a fraction left, technically, I don't have to use the parentheses around my number. Because when you got fractions like this, it's implied that the top and bottom are in imaginary parentheses, okay? So this one we had to keep the parentheses because this wasn't a fraction or anything. But when you got a fraction like this, you don't have to keep the parentheses. So that was the trick on 9.5 was that we mainly used those three properties of logarithms, okay? All right, y'all. So next on the agenda will be our 9.6 support. And this one sort of deals with solving equations. But I'm going to recall y'all on something here. If A over B equals C over D, then, so if you got fraction equal to a fraction, to solve this, we cross multiply. So I would do A times D on one side. That's going to equal the B times the C on the other side. So just going back, when you got fraction equal to a fraction, we cross multiply to get rid of the fractions. So number 1 says solve. X minus 8 over x plus 3 equals 4/5. So look, I got a fraction equal to a fraction like right here. So I'm going to cross multiply. So this x plus 8 multiplies times the 5. So that's going to give me 5 times x, which is 5x. 5 times negative 8 is negative 40. So the 5 has to multiply by both of these, okay? Just like on the other side, this x plus 3, both of them gotta multiply by that 4. So you would do 4 times x, which is 4x. 4 times 3 is a positive 12. Y'all, the fraction is gone. Now we're going to solve for x. So my first step, I would move the 4x over here by subtracting 4x. So 5x minus 4x will leave you an x minus your 40. Over here, those x's cancel. All that's left is a 12. All right, y'all, my final step. Get the x by itself. I would add 40. So add 40 to both sides. I get my x. Those cancel. And then 12 plus 40 gives us 52. So checking these answers. If you want to check, put the 52 in for the x's. 52 minus 8 over 52 plus 3 has to equal 4/5. All right, let's see. 52 minus 8 is 44. 52 plus 3 is 55. That has to equal 4/5. Well, y'all, if you reduce this fraction, you would divide the top and bottom by 11, because 11 is the largest factor.
Hancock's English course. I can't speak today. This is part 2 to the analytical essay writing. And this one is good.
Now notice it checks out. 4/5 equals 4/5. So that answer checks. So if you want to check your answers, that's all you're doing. Plug those answers in and see if it is a true situation going on, okay? Hey, oh, y'all, it's break time. So let me pause this there for a second. All righty, y'all. So number 2 was another solve. Z plus 3 over Z equals 3/2. You know, I'm going to do the same thing. Start out by cross multiplying the Z plus 3 times 2. So 2 times Z is 2Z. 2 times 3 is a plus 6. That'll equal the other side, which is this Z times 3, which is 3Z. So y'all, I got a variable and a number here and just a variable here. So the easiest way to solve this is to subtract 2Z from both sides. So those cancel, and I got my 6 equals 3 minus 2 leaves me 1Z. And y'all, really, that's what the first 3 were doing. We're doing a lot of cross multiplying here. 7 over 3y minus 2 equals 4 over 9y. Because when we do 9.6, we're going to be doing a little bit of cross multiplying on part of that, okay? All right, y'all, so take the 7 times 9y gives you 63y. That's going to equal both of these multiplied by that 4. So 4 times 3y gives you 12y. And then 4 times negative 2 gives you negative 8. Now y'all, so the variable equal to a variable and a number. I'm going to move this variable over here to get my y's all on one side. All right, y'all, let's see. 63 minus 12 is what? 51y. Those cancel. All that's left is negative 8. All right, so it looks like our last step, divide both sides by 51. And that'll equal negative 8 divided by 51. So those cancel, giving me my y. And y'all, I'm trying to think, I don't think that one will simplify, so that gives me a negative 8 over 51. So the first 3 were just getting y'all good at doing this cross multiplying stuff, okay? In order to get rid of fractions, using this property right here. So there's 2 more in the support. So number 4 was a solve. But now they're changing the problems up. This one I got a c squared minus 7c minus 8 equal to 0. So they want us to solve a few doing a little factoring. So this is a trinomial. So I'm going to start it out with 2 sets of parentheses. And we're going to factor this. The c squared will be a c and a c. Now, the last number's negative. Anytime the last number's negative, you got unlike signs for your two factors. And it also tells me to find factors of 8 that subtract to equal 7. So y'all, 8 is 1 and 8, 2 and 4. The factors that'll give me 7 are 8 and 1. The larger number will be negative like the middle. So the 8 will be negative and the 7 will be positive. At that point, I'm going to set both them equal to 0 and finish solving this. So here we would subtract 1 from both sides. And on this one, we would add 8 to both sides. Now this one you could have graphed. Remember, you can graph this one and you would have got these two answers. It would have crossed over at -1 and it would have crossed over at 8. Now this last one, I probably will graph this one to solve this one, I probably will graph this one because it's got a number in the front. 2x squared minus 7x plus 6 equal to 0. Since there's a number in front, these ones are pretty much easier to solve by graphing. But you're going to have to do the little trick since you got that 2 in front, okay? So remember, when I graph this, since I got a 2 in the front, I'm going to go to the table. What do they call it? The table set. And I'm going to change that triangle. I'm going to change that to a 1/2. And I'll show you what I'm talking about. So let me go to the calculator. I'm going to go to y equals. Let's put that in. 2x squared minus 7x plus 6. Now, I'll show you the table right off the bat by going to the second graph and going to the table. And I got a 0 at 2. So I know that's one of my answers. And I'm just going through here. And it's hard to tell where the other one's at. So watch what I do. I'm going to graph it to sort of estimate where I'm going to be at. Oh, y'all, it's hard to see that. Let me zoom that in just a second. Zoom in number 2. All right, so when I zoom it in, you can tell on the right side, that's going through 2. But there's another point on the left side. I can't tell what that is because that's in between 1 and 2. So it's going to be in between the 1 and 2. So I'm going to hit this blue second button and the window button to go to table set. Down here on the triangle table, I'm going to change that to 1/2. So remember, you always make a fraction. If you got a number in the front, the denominator will always be that first number. So now when I go to my table, second graph, let me head to the right side. Oh, at 1.5, I got a 0. And at 2, I got a 0. So those are my two numbers, 2 and 1.5. Now, that 1.5, I'm going to turn that into a fraction. So 1.5, hit math and enter twice. and that gives me a 3/2. So my answers would be 2 and 3/2. So y'all, x equals 2, x equals 3/2. That's how to do this one by graphing it. Now doing this one by hand, I'm going to show you how I can get the same answers as that did, okay? Doing it by hand. Now the trick on this one is you got to multiply the 2 times 6. So 2 times 6 equals 12. If you got a number in the front, you got to multiply it by the back number. 12 is the number I'm going to find my factors of. So y'all, here we go. The x squared, you'll still put an x and an x. The last one's positive, so both of these factors will be negative like the first. Now here's the trick. Since you multiplied 2 times 6 to get 12, we got to find factors of 12 that'll add to get 7. So 12 is 1 times 12, 2 times 6, 3 times 4. The factors that'll equal 7 are 3 and 4. Now, y'all, here's the difference between this and this one. Anytime you got a number in the front and you multiply by the last number to get to 12, when you get to this point right here and you got your two numbers, you got to divide them both by that 2. You got to divide by the first number that you borrowed to get to 12, okay? Now, will these simplify? Well, this one I can't simplify. But y'all, the second one I can simplify because 4 divided by 2 gives me a 2. So, set both these equal to 0 now and solve. So this one I would add 3/4 to both sides. Whoops, my bad, y'all. How did I turn that 2 into a 4? That's a 2. Okay, so somehow I turned this 2 into a 4, but remember, that's still a 3/2, 3/2, and we're adding 3/2 to both sides so that we get x equals a positive 3/2. Well, that's one of the answers we got factoring. And then here, I would add 2 to both sides. Again, x is a positive 2. So y'all, you can graph these and change that triangle table to a 1/2, or you can do it by hand, but the number in front has to be multiplied by the last number, and then you find factors of that number that equal the middle number. Once you got the two numbers, you got to divide that 2 out of these. So you borrow the 2, but then you divide it back out, okay? Either way y'all want to solve those is fine with me. All righty, y'all. Whoops, we just did 9 pounds. This is 9/6. And I'm not going to do much of 9/6. I just want to do a little bit of a preview of it. But 9/6 will be solving exponential and logarithmic equations. All right, do y'all remember tomorrow? I won't be able to start class till about 10:30 to 10:45. So remember that, okay? All right, y'all, first we will solve exponential. So I might go through the exponential, and then when we get to the logarithmic part, I'll save that for tomorrow, okay? So solve an exponential. We got a property that helps us, and this is called the base exponent property. But y'all, this tells me if a to the x equals a to the y, so if you got two sides equal with the same base, that means the exponents have to be equal. Right, so if this was 2 to the x equals 2 to the y, then since they both would have 2's here, the exponents are equal. All right, so to solve exponential, my first thing is, can I rewrite it using the same base? So if possible, rewrite using same base. Because if I can rewrite it using the same base, that means the exponents will be equal. All right, so if I rewrite it using the same base, set exponents equal to each other, solve for the variable. Now, if can't be rewritten using the same base. So I'm either going to be able to rewrite them using the same base and do this. If I can't rewrite them using the same base, I'm going to take the log or ln of both sides. Because y'all, what happens if I take the log or the ln of both sides, I can then use the power rule and bring the exponents down to the front. Using power rule, bring exponents down. Y'all, once I brought that exponent down, I'm then going to solve for the variable. And then check if needed. Okay, y'all, so that's the steps I'm going to follow. So let's go through a few of these and I'll sort of show you what I'm talking about here, okay? And they'll sort of mix it up between some that I can rewrite and some that I can't. But here's the thing. Even if you can't rewrite them or you don't know that they rewrite, you can still solve them doing this way every time by doing the log stuff, okay? But it's a little quicker if you can rewrite them. See, all these are going to say solve for x. So 2 to the x equals 16. So what you gotta look at in order to rewrite these, you got a 2 to the x over here. So 2 is the base. Can I rewrite this 16 as 2 to some exponent? So can I rewrite a 2 with some exponent here that would represent 16? So y'all, take a 2 and start multiplying by itself. 2 times 2 is 4. Times 2, so 4 times 2 is 8. Times 2, well, 8 times 2 is 16. So I can rewrite 16 using a bunch of 2's. So that'll be 2 to the 4th power. So this will give me 2 to the x equals 2 to the 4th power. So that was this. Yes, we could rewrite it. So now these bases match. So since these bases match, that means the exponents are equal to each other, and x equals 4. Now, if y'all wanted to check that, you would take this 4 and put it in for that x. 2 to the 4th equals 16. Well, y'all, we proved that right here. So this answer is correct. So y'all, these ain't that bad. Watch this one. 6 to the 4x equals 216. So here's the question on this one. Can I rewrite 216 as 6 to some exponent? Let's try that. 6 times 6 is 36. 36 times 6. Oh, look at that. 36 times 6 is 216. So since I did that 3 times, I could rewrite this as 6 to the 3rd power. So y'all, I get 6 to the 4x. So I could rewrite that one again, yes, equals 6 to the 3rd. All right, so the bases match. So that means the exponents are equal. So 4x equals 3. And y'all solving that for the x, I divide both sides by 4. That cancels, and the x equals 3/4. Well, if you put 3/4 in here, the 4's cancel. 6 to the 3rd equals 6 to the 3rd. Or 6 to the 3rd equals 216. Y'all, these work out once you go through them if you can rewrite these, okay, and then plug those answers back in for the x's. So y'all, let's try one that you cannot rewrite. So this will be our number 3. Solve 2 to the x equals 23. So my base is a 2. So my first question, can I rewrite 23 as 2 to some exponent? Well, there's no way I can turn a 2 into a 23. Right? We know 2 to the 4th was 16. 16 times 2 is 32. So you can't turn a 2 into a 23. So that would be a no on that. So I cannot rewrite it. So since I cannot rewrite it, I'm going to take logs of both sides. And y'all, that goes back to the property if A equals B, then the log of A equals the log of B. Basically, what I do to one side, I got to do to the other. So if I take the logs of this side, I got to take the log of that side. So I get the log of 2 to the x equals a log of 23. So remember on my instructions, after I took the logs, the whole reason we're taking logs is now I can use the power rule over here and bring that x down to the front. So that I get a x log 2 equals my log 23. So x times log 2 equals log of 23. My final step is to divide both sides by the log of 2. So x times log of 2 divided by the log of 2 equals the log of 23 divided by the log of 2. So y'all, these logs cancel and I get my x equals. Now over here, we got to do these on the calculator. And these logs will give you a parentheses. When you put in your number, make sure you close them, okay? So let me go to the calculator. No, you also I would do the log, put in my 23, close parentheses, divided by log of 2, close parentheses. And anytime you got to do the log stuff, you got to round these out 4 decimal places. So y'all, this would be what, a 4.523. So the 5 is in the 4th spot, but it's got a 6 behind it. So I'll turn that 5 into a 6. So I got 4.5236. And y'all, that's the trick on these, rounding them out when you get to that final answer, okay? All right, y'all, let's try another one. 4, 2 to the 7x minus 1 equals 16. Oh, y'all, we know on this one we can rewrite 16. So can I rewrite 16 as my base, which is a 2 to an exponent? And we knew that we could do that if that was 2 to the 4th. So this one we could do that. So let's do it. We got 2 to the 7x minus 1 equals 2 to the 4th. So y'all were happy. These bases match. So that means 7x minus 1 equals 4. So we're going to solve that for the x. So we will what? Add 1 to both sides. 7x equals 5, because that stuff cancels. And then divide both sides by 7. See, all that cancels, giving me my 1x equals a 5/7. If you put the 5/7 up here, the 7's cancel, giving me 5 minus 1, which is 4, and 2 to the 4th equals 16. So y'all really, that's the trick on these, determining whether you can rewrite these or not, okay? 3 to the x equals 8. Can I rewrite an 8 using a 3? Well, 3 to the first is 3. So that'd be like 3 times 3. Well, 3 times 3 is 9. That's too big. So no, I cannot rewrite this one using threes. So we can't rewrite. That means we're going to take a log of both sides. So that first move determines how I'm solving these, okay? So I'm going to take the log of both sides. So log of 3 to the x equals the log of 8. We did that so that we can bring that x down and get an x log 3 equals log 8. So y'all remember my last step, divide both sides by log 3. So those will cancel, get my x. Remember, close the parentheses on that one. So y'all, let's go see. We got a log 8 divided by log 3. So log 8 divided by log 3. All right, we're rounding this out 4 spots. So 1.892. Right, that's a 7, but it's got an 8 after it. So we'll turn the 7 into an 8. All right, y'all, let me see. This one has e to the t equals 525. All right, well, I can't rewrite this one using the base e. So if you got an E, you can't rewrite it. But on this one, I'm going to be picky. Instead of taking the logs, anytime you got an E here, you want to take the LN of both sides. So watch this. LN of E to the T equals the LN of 525. Well, y'all ought to recall y'all on something. This LN is really a log base E in disguise. So I've got a log base E of E to the T. Anytime you take the ln of E to an exponent, it equals the exponent. Okay, this ln of E to the T will always equal that exponent. Now, on the right side, I actually got to take the ln of the 525. But I like these a little better because the E sort of goes off and you don't have to do the dividing part. You just actually got to take the ln of the 525. So y'all will go to our calculator. All right, LN's on the front. Throw in 525. Hit enter. And we'll make that a 6.26. 3. And that 3 has a 9 after it, so I'll make that second 3 into a 4. Oh, y'all, so that's the trick on these. Hey, y'all, so I'm going to save the logarithmic equations till tomorrow, okay? So what did I get up to? So y'all should be able to, if you want to, for 9, 6, you should be able to work up to at least number 6 or so, okay? All right, so Friday tomorrow, remember, class will start around 10:30 to 10:45. I should definitely be back by 10:30, but give me till at least 10:45, okay? So we'll start class then, and it won't be very long because all we got to do is finish up 9-6 and then do a little bit of and 9-7 is pretty quick. So we'll finish up 9-6. And then I'll probably wait till Monday to do 9-7. But y'all don't worry. If I can't get back here during these times, if y'all all go and I'm not on here by 10:45, I will do both of these on Monday if I got to. Okay. So 9-6 ain't due until the same time as 9-7. And I made them both do the 31st instead of the 28th. Because these are like the last two sections we got to do in this whole class. So if I ain't back by 10:30 to 10:45, I don't want y'all waiting no further than that. We'll do these on Monday. If I am here, we'll knock out 9.6, finish it tomorrow, okay? All right, y'all. Remember this, test 3 is due Sunday night for y'all. And let's see. No, that's all I got. So do y'all have any questions?
No.
All right, y'all. So, we got one more week of class. Remember, next Thursday is it for this class, okay? So anything that you're behind, you gotta catch up this weekend, okay? All right, y'all. I don't have anything else, so I will see you all tomorrow, hopefully at 10:30, okay?
Okay, thank you.
All right, y'all have a good day.